this on? Yeah. Hi, thanks, Andy. Everyone, welcome to the Spark Summit. I'm very delighted to be here. And I think Databricks has done a fantastic job of starting a company and bringing out what they've been working on for the last several years out into open, as a company with full support and everything else. So quick introduction about who MapR is. For people who don't know, so we were ranked the #1 Hadoop distribution by a lot of the research people. We've had phenomenal sales, and a lot of top customers started using MapR now, and both Google and Amazon provide MapR as the Hadoop distribution on their clouds. So as part of, Hadoop is actually not one thing. It's these thousands of different projects almost seems like. If you work on Hadoop especially, there's something new coming out every day. And so what MapR tries to do is try to provide as much as possible as what's popular among the Hadoop users as part of the MapR distribution. So today we'll focus on the complete Spark stack on Hadoop, and MapR is probably the only distribution that's giving you everything that's there in Spark. And we'll talk about that. So Spark and Hadoop, we found it's a really, really winning combination. And why is that, right? Basically, some of the advantages of Spark that you've heard over and over again from everybody here is, firstly, the ease of development. The APIs are really beautiful. I think somebody presented yesterday how simple it is to write even a simple MapReduce program. And the language support is just phenomenal. So we are pretty excited to be part of this. The other big thing is in-memory performance, right? I mean, MapReduce forces you to go to disk constantly. And what we have found is a lot of things can be done in memory much better. I mean, as everybody knows, it's the best thing. But the problem with in-memory always has been, how do you solve the reliability problem? How do you put things in memory and yet make things reliable? And Spark really came out with this really innovative thing called RDDs. And I think everybody here probably knows or has used it. But we thought that was worth pointing out over and over again. The other interesting aspect about Spark, and as you saw in the previous slideshow by the previous speaker, was that, hey, here's the Spark core, and here's this runtime that runs everything, and everything on top of that is a bunch of libraries. Well, what's very unique about the runtime is that they do directed acyclic graphs. And pretty much it's a data flow processing model that you can really represent any kind of computation with it, right? So this is, and that's what you see as part of the Spark library offering, which is all these different processing models, whether it's graph processing or MapReduce or SQL or machine learning, can actually be unified using DAGs. The other interesting thing, okay, so I just talked about that, right? You can combine the workflows. And what does Hadoop really bring, which is very, very complementary to Spark, is it really brings unlimited scale, right? You have multiple applications it can host. It's a standard processing framework for all kinds of different things on it, and it's proven to scale pretty much indefinitely. The other thing that Hadoop has now evolved into after the last 5-6 years I've been involved with it is it's really grown into a multi-tenant, fully like a true enterprise-grade data center platform. And Spark is a great complement there because it provides the processing on top of this platform. And of course, like I said, one size fits all. Hadoop tries to get there, but of course it doesn't. I mean, but on the real thing is that files, databases, or in memory, or semi-structured or fully structured, I think you see Hadoop trying to tackle everything. So really, the combination can take what was traditionally batch processing on Hadoop and move it to what I would call as operational applications, where data is processed as soon as it arrives in memory, and you can actually take decisions on it and combine different kinds of workflows. So for example, inside my SQL code, I can say, hey, by the way, why don't I just call this machine learning library to learn a little bit more about this? Or I can do approximate calculations with BlinkDB, or I can do, process Flume coming in and immediately get insights into, with Spark streaming and do micro batches and so on. I think it's more interesting. I can go on and on about the technology, but it's more interesting to talk about some of our customers who have started using this already. And these guys are already in production. So one of a leading ad targeting platform, they use MapR's M7, and M7 is about, I think, about 10x or so the performance of standard HBase, and you can ingest data at almost like 1 million ops a second per server, right? And they capture this data coming in because the response time requirements are, in under 5 milliseconds for read or write. But then they have to do real-time scoring on this data. So they load the data from the M7 table into RDDs and augment the scoring in real time. And this is happening continuously at almost like 100 billion transactions a day. I mean, that's the kind of rates we're talking about here. And then the results are actually fed back to another table where now you can do other kinds of interesting work like pricing and so on based on what happened with what we just learned, right? Or actually control the ad targeting program so that you don't exceed the budget of the advertiser very quickly. Another great use case of Spark out here was in genomics. We have a very big pharmaceutical company already using Spark. And what they do is that, I don't know if you've done genomics, the main problem in genomics is trying to sequence your genes. And it's a really NP-hard problem there, where you have a standard genome sequence from a healthy person, and you sample the genome from the patient, and then you try to find out what are the anomalies, right? And mostly it's aligning the genes together on a sequence of those 4 bases. And it's very, very, extremely compute intensive, extremely slow. And if you look at many of the genomic companies that do this, a single sequence matching takes about 4 or 5 hours on a large cluster, running completely in memory. So Adam on Spark allows the realignment in a few hours compared to like using traditional HPCC kind of techniques. The traditional HPCC techniques would have a massive, like a RAID array or something. It's a centralized SAN storage that keeps the raw sequences as they come in. And then this is actually a giant sorting problem as far as genome sequencing is concerned. And Adam on Spark is a great example of where this pharmaceutical found incredible improvements in their standard processing using Spark. And most importantly, they could now minimize their engineering dependency on every time they change something or they want to try a new algorithm or something. Genome sequencing, the secondary analytics, is exactly like machine learning, where you keep trying different things until you say, okay, maybe this works well. And it's a pretty labor-intensive, and going back and forth between the genetic scientists and the computer scientists has really been a language translation problem. Another great example of this is Cisco is doing a security intelligence operations product based on Spark and M7. So they have sensor data coming in from all different kinds of sources, whether it's firewalls, mobile information, campus information, and so on. And it lands in M7. Again, the data capture rates have to be tremendously high for this to happen. And then Spark streaming is used on M7 just to check for known threats first. And as soon as it arrives, you look at it immediately and say, hey, do I know this? Flag it right away and kick it out. But then next, they want to correlate the data that went past the first threat analysis and figure out, is there a correlated event that's happening because of this, right? And so they use machine learning with graph traversal. And this is where really the entire Spark platform helps out, because it's really the same platform. You can actually express both streaming and graph traversal within the same environment. And finally, they actually use SQL to query the results to figure out, what are the kind of threats I've seen in the last 3 days, or what kind of correlated things are happening where if I see it from this firewall and this printer and this set of mobile phones somebody brought into the company, am I seeing these kinds of threats or not? So this is actually a deployed application running on Shark and Impala. And I think there was a talk on this also that I think Cisco might have given at a Hadoop user group sometime in the recent past. Another great example is a health insurance giant addressing healthcare regulations, right? So again, they're using M7 to capture the data. M7 is really like a NoSQL database, but it's a little bit way more reliable than most standard NoSQL databases. There's no compactions. It does automatic splitting and sharding, automatic recombination. They are using M7 to keep clinical records inside this database. Now, clinical records require extreme amount of, there's all kinds of HIPAA regulations. So the kind of security you need is extreme here. But what they want to do is, with these clinical records, they want to compute the probability of readmittance, right? So what they do, they use Spark with this transactional data that they're getting about, okay, this test was performed, this visit happened, this happened, that happened, and they're trying to see if they can actually figure out that in real time, what are the options they can give the patient when the patient comes and looks at their test results, or they have a conversation with the doctor, or the doctor logs on and talks about, looks at the test results and so on. So this is actually a very real-time operational kind of work that Spark really brought to Hadoop. And so it's a pretty, we are very excited because we already have lots of deployments of Spark on MapR. And I think we're really looking forward to a very long partnership with Databricks on this. So to keep a long story short, real time is here with Hadoop now. Spark brings it. But again, remember, you got to pick the right tool for the right job. Not everything always is in memory, right? I mean, you have to worry about what happens when things leave memory. While in-memory is great, you cannot throw memory always at the problem, right? So you actually have to, if I look at, so pick the right tool for the job here. I think an example that was given earlier is that, hey, for SQL, Spark is great, but sometimes direct SQL might be actually better. But Spark is great. And MapR really gives you the entire Hadoop stack, just like you would expect from somebody like Linux, right? When, for example, Linux gives you HTTPD or NGINX or Lite TPD or whatever it's called, or you get MySQL, Postgres, or SQLite. MapR actually provides you unbiased open source, whether you want Spark and Shark and all its sister projects, or if you want any of the SQL, the pure SQL guys on Hadoop, like Impala or Drill or Shark or Hive-Taz, or if you want various versions of Hive or HBase or Pig, we provide them simultaneously at the same time on the same cluster. So thank you very much. Please engage with us, and very delighted to be here. Congratulations to Databricks.